Hello and welcome, my name is Raphael and I'm the designer of the Mammut Low End Shaper. Today we will have a closer look at the device and its capabilities. Even though this is a stereo device, it can still be used in mono, which I will show in another video. So I'll just be focusing on stereo bus operation here. As the low end is one of the, if not the most difficult frequency bands to get right, the Mammut was specifically made to tackle this area. It has some unique features to help sculpt the low end in an easy and quick way, and we're going to look at them now. Looking at the front panel, imagine the signal flowing from left to right through the controls. On the left half, these controls operate on the entire spectrum of the source material, but on the right half, these only operate on the low band frequencies as selected by the crossover filter, but more on that later. First, we have a unique high-pass filter. This is not your box standard, let me cut out the rumble filter. You can choose between a traditional 12 dB per octave and a special 18 dB per octave slope, and this filter truly shines in this 18 dB mode. This lets you clean up the rumble while barely touching the frequencies you still want to keep, and at the same time it kind of glues the lowest frequencies together and makes them more coherent. It also emphasizes the transients and helps the instruments cut through the mix. The next stage is a variable shelf EQ. As its name suggests, it's not just a regular low shelf filter, as it is much more versatile like an EQ. It has been specifically designed for the Mammut. This low shelf is band limited by the adjustable low and high frequency controls. This lets you merge the shelf to a sort of unique bell curve, and the two frequency points can even be swapped to create even more curves. The most remarkable feature is that, depending on the gain setting, there is a more or less pronounced boost or cut right outside of the desired filter frequencies. This helps to carve out the area of interest and give it more room or focus. At a closer look, this curve is reminiscent of the Pultec EQ boost cut effect. Next up is the crossover filter, which I previously mentioned. This is where the signal is split into two bands at the selected frequency point. The low band, which is fed into the compressor and saturation stages, and the high band, which is not being processed and not touched at all. After processing the low band, it is reunited here with the high band and the signal is sent to the output. There is a button located right underneath the crossover control. This button enables the listen mode, which disables the high band and lets you single out the low band and its subsequent processing effects. This helps to hear what exactly is being sent to the compressor and saturation and what kind of harmonics are created in the process. Choosing a higher crossover frequency will incorporate more of the instrument's body and includes things like snares, which will then be processed too. Now we are at the heart of the Mammut, the compressor expander core. While it still bears the name of a compressor, you must forget everything you know about compression when it comes to this. While it still does compress, try to think of it more like a wave shaper, because the goal of this stage is not only to compress or expand the signal, but to create complex harmonics that emphasize it in a musical way. It has the usual controls of threshold, makeup gain, ratio, attack, and release, and in the center we have the gain reduction meter. Additionally, we have a soft knee mode, a button to switch compression to expansion, and a button to switch the makeup gain to attenuation instead. This makeup gain / attenuation control works like a true traditional shelf filter as opposed to the variable shelf EQ type. Due to the construction of this stage, this shelf filter has a unique and precise slope with no overshoot and can be used all by itself without having to use any compression. And you won't find no other like this. An important focus lies on the attack and release controls. This is where the biggest deviation from a standard compressor comes into play. Think of these controls as a frequency selection knife that lets you grab single waveforms in the low band with scalpel precision. Attack sets the limit of the lowest frequencies being shaped from about 10 Hz to the frequency denoted by the attack time. The slower the attack, the more of a single wave of such low frequency can pass unaltered, which reduces the applied gain reduction and with that the generated harmonics. Release sets the bandwidth of influence on the higher frequencies and signals that are quieter than the current peak, starting from the attack time up to the release time. This enables you to select a specific region of timbre of an instrument. But these bandwidth limits of both controls are gradual and their influence is much more complex than it might seem. And last is the saturation stage. This saturation stage only processes the low band, as is the compressor, and is based around a steel-nickel transformer, which is used to generate odd order harmonics. This adds clarity and presence to the low end and helps it cut through the mix and adds life to digital sounding material. Additionally, there is a button to activate even order harmonics which can be added in a low or high setting. This will give you warmth and a sort of organic smack. This stage is normally behind the compressor but can be switched in front of it to get even more sonic options. The large central button is the hard bypass switch, which is relay based, so you can completely remove the device from the chain. I would like to quickly mention some details about the controls. The knobs are our own design and are machined from aluminum. The high quality switches are all stepped with a distinct click as with any other hardware device. Only the threshold knob is a 360-degree continuous potentiometer.